Solve linear systems graphically. Question 1. Solve the given linear system graphically. Y equals to x minus 2 and y equals to minus 2x plus 1. Well, here is a series on solving linear systems graphically. So I'll consider a number of examples so that you get overall picture of how to solve a linear system graphically. Let's first understand what does it mean. Now, the heading here is solve linear systems graphically. Now, linear means straight lines. So anything which is to deal with straight lines like this, that means we are dealing with linear things. Systems involve more than one, right? So something which has more than one will form a system, right? So maybe in this case when we say linear systems, it means more than one line. So let the other line be like this, correct? So that makes a system. When we have more than one line, it is called linear system, okay? Now, solve linear system. Solve linear system implies that we are interested in finding this point of interaction between the two. So let's say we have two lines, one shown with the blue line, the other red line. Then the solution of this system having these two lines is their point of intersection, that point of intersection, correct? And how do we find that point of intersection? So in this set of videos, we are trying to find it graphically, right? So that gives the meaning to our heading, solve linear systems graphically. That means in all our examples, we'll have more than one line. In fact, we'll have only two lines. And then we are going to find this point of intersection, which is called the solution, graphically, correct? The other method is algebraic method, where we have used substitution and elimination method, okay? So once you are done with graphical, you get a good picture of how the solution should be, right? And what type of solution you are looking for. And then explore the algebraic solutions also, correct? Now let me tell you here that as shown here, the two lines will normally intersect at a point, but it is not always so. Sometimes the lines could be parallel, correct? So we had this blue line, and if the red line is parallel to it, then they will never intersect, right? Parallel lines I cannot draw so accurately, so what I will do at times, make some arrows like this. That set of arrows which are similar indicates that these two lines are parallel, okay? So how many points of intersections will these two lines have? None, because they will never intersect, right? So we say this set of linear system does not have any solution, correct? And how about this? If we have the other line exactly over the previous line, so both are kind of same lines, right? So they are parallel also, but they are same coincident, they overlap. How many solutions will they have? Well, this set of lines will have infinite solution, correct? Because they overlap at each and every point, correct? A point is a line is a set of points, and there are infinite points on a line, and since they overlap on all the points, it has infinite solution. And this set, which is parallel lines, correct? They have no solution. And these intersecting lines, they always intersect at one point, and therefore this is one solution, okay? So remember that. So we can get one solution, no solution, or infinite solution, correct? Now let's begin with question 1. It says, solve the given linear system graphically. So we have two lines here, okay? So let's consider this to be the first line and that to be the second line. To graph, you have already seen the video set on graphing lines. If not, go to that, and then graphing will be such an easy thing for you. Now here it is. y equals to x minus 2. So what is the y-intercept? Y-intercept is minus 2. And what is the slope? Slope is 1. So for this line, we have y-intercept, that is b, yb. I'm comparing it with y equals to mx plus b, right? Slope-intercept form. So b, the y-intercept is equals to minus 2, and slope, I'll write it in fractions, 1. So I'll write 1 over 1, mainly because you got it. Rise over run, correct? Rise over run is my slope, right? That's the slope I'm talking about. And in this case, both rise and run are 1, correct? So y-intercept is minus 2, so that's my first point at minus 2. And then from here, we take rise of 1 and run of 1, correct? And get the other point, which is this. And then again, rise of 1 and run of 1 gives me the third point. Normally, I'll take 3 points to join and make my straight line, correct? And here is the straight line joining these points. Let me draw it in blue itself. So that's my blue line. Well, I'm not really following this color code in my videos, but this one, well, we started with red and blue. Let's finish with red and blue, okay? Now the second statement, second equation of line is y equals to minus 2x plus 1. The y-intercept is plus 1. So that is my plus 1, and slope is minus 2. So let me write down this slope separately as m equals to minus 2. That means minus 2 over 1, right? Minus 2 means 2 units down and 1 unit right. So let's go 2 units down, 1 and 2. Use different colors so that it doesn't mix it with 2 and 1 unit right. That means, oh, we got a point of intersection also here. That's great. So that's also our solution, right? Then again, we can go 2 units down and 1 unit right. So 1 and 2 and then 1 unit right. Sorry, we have to go from here, I'm sorry. So from the point where we reach, you go 2 units down, because this is the first point, that's the second point. So we'll go 2 units down, 1, 2, and 1 unit right. So 1 unit right gives us the third point. So let's join these points and see where do these lines intersect. So at times graphically we don't really get very accurate answer, right? But these questions which I have selected, they are so that they intersect at a good point and you can very easily read the solution, right? Now here, this is our solution, the point where both the lines intersect. And we say, well, solution here is of this linear system is this coordinate of the point 1 minus 1. The x value should be written always first, which is x, and the y value is minus 1. The ordered pair 1 minus 1 provides us with a solution to this particular system. Now it's a good idea to check. I'm not going to check in the following videos, but I'm going to tell you here so that you can check it on your own whether this is the right solution or not. One way to check is just plug in the x value and see if you get that y value. So if I plug in 1 here, 1 minus 2 is minus 1, that's correct. So I got the same coordinate, right? Here if I put 1 for x, I get minus 2 times 1 is minus 2. Minus 2 plus 1 is minus 1. So that's correct. So that's one way to check it. Second is plug in both x and y. So we'll write x as 1, y as minus 1 and see if the equation is true. So say minus 1, let me write like that. Minus 1 equals to 1 for x. 1 minus 2. Yes, I get minus 1 equals to minus 1. So that's perfect. And here if I check, I can write minus 1 for y. Here it is, minus 1 for y. And minus 2 times 1 plus 1, which is also minus 1. So that's true. So these are the ways to check. So we checked our answer and we found it perfectly matches. So that's a perfect solution to our linear system, which we found graphically, correct? So that is how you are going to solve and practice. After about 6-7 videos, you should be master in it, okay? And then move on to solving linear systems algebraically. Thank you and all the best.